Hi, and welcome to Seebo's videocast series. Hello, Liran.
Hello, Noah.
So, if you're in manufacturing, then you've probably heard all the buzzwords. AI, machine learning, Industry 4.0, smart manufacturing, and on and on. But buzzwords aside, there's a world of potential out there. How can you, as a manufacturing executive, make sense of the noise to identify the new technologies that will truly address your most pressing business problems? Liran, you've had a lot of experience working with leading manufacturers to do just that. In your experience, is there a silver bullet out there? I mean, how can manufacturing executives identify the right AI solution to meet their challenges, particularly when it comes to reducing production losses?
So, Noah, unfortunately, not. There is no one silver bullet that can solve all manufacturing challenges. Actually, there is a lot of noise in the market. A lot of companies are speaking about artificial intelligence for manufacturing. A lot of consultants out there tells the stories of the magic of artificial intelligence. And many manufacturing executives are actually asking themselves, all right, I understand the potential, I want to do it, but what is the right technology for me? And actually, on answering right this question, it's meaningful, it's critical. Once you're going to choose the technology, there will be a budget and purchasing and IT and security and teams working around the technology that you chose. And simply, if it's not right, it will not succeed. The cool thing is that there is a pretty good methodology of identifying what is the right technology for your needs. And if it's okay, I'm happy to share it with you.
Yes, please.
So before we even think or speak about artificial intelligence or even problem solving or computers, let's think about how humans solve problems. And the way, I'm not sure if you noticed that on yourself, but the way people solve problems depends on the frequency of the problem. I'll give you an example. If you have a frequent problem that you have many examples of, you will look for the pattern of the problem and try to solve it. While from the other hand, if there is no frequent problem or infrequent problem, since you haven't seen the problem enough, you will not try to look for the pattern. You would ask yourself, what is the state? Am I in a good state or a bad state? Now, funny enough, computers think about problem solving the same way. In the professional language, it's called supervised learning or machine learning versus unsupervised machine learning. So computers, when they see a frequent problem, will try to build a model of the problem and ask, are we in the model of the problem? Are we currently in the problem state? While computers, once they look on infrequent problems, since they cannot build a model, they would simply ask, are we doing okay or not? Now, I'll give you an example. Let's say that I have a pump that is failing once a year, once every 2 years. And probably when it fails, it's from different reasons. Since I haven't seen how a failure looks like from the data point of view, I cannot try to model it. I'll simply ask, is this pump okay or not? From the other hand, if I have a frequent problem, let's take overweight in bread baking. This is something that happens 20 times a minute. So I have plenty of data about that, and I can model that. And then I can ask myself, is this bread going to be too heavy or not? So now, let's go back to the methodology. The methodology always starts with your business. Map your losses. Simply create a list of the things that you would like to solve and prioritize this list. Think that this is an achievable task. The next thing you should do is you should take each one of the problems that you mapped and prioritized and put them on this quadrant. And I like to explain the beauty about this quadrant. Here we can see problems that are process-driven and problems that are asset-driven. From the other hand, we can see problems that are with high frequency and problems with low frequency. Now let's go back to our previous example. The problem of the bread overweight, as we discussed, happened 20 times a minute, and it's related to the process. to the relationship between the humidity of the dough and the temperature of the oven and the speed of conveyor in the oven. So that goes on quadrant 1, process-based and high frequency. So here we require process-based supervised learning. Let's take the other example, the pump challenge. Here it's an asset-driven. It's a pump problem, and it's rare. It's not happening frequently. So here we need unsupervised learning on a specific asset. Now, what you saw here is that once you understand the problem, is it asset-based or process-based, is it frequent or infrequent, you can actually understand if you need supervised learning or unsupervised learning. And now, as a manufacturing executive, you can ask your supplier or AI consultant, are you doing supervised learning or unsupervised learning? What is your expertise? Just one nice example about that. Let's imagine that someone from the moon will come to Earth or from the space, and they will try to understand playing with ball. They will see people throwing the ball onto a net. Some people throw it over the net, and some people with the foot into the net. Probably sounds all the same, right? It's all playing with ball. But then one day you discover that there is Michael Jordan, Federer, and Messi. And those are completely different expertise. And this is the same with data science. A company or a vendor that is doing supervised learning, and if they do it really well, they cannot do unsupervised learning. And the other way around. So you need also to make sure that you're working with a team that is really focusing on their need. Let's go to the asset-driven, high-frequency problems. A pump that fails every day, twice a day. The cool thing about this quadrant is that you need to understand if you can find a process proxy. For example, measure the pressure of the pump. If you can find a process proxy, you move it to quadrant 1. So you would solve this problem based on quadrant 1. And if you cannot find a process proxy, solve it with quadrant 4. Quadrant 3 is a bit more rare, and here you would need an unsupervised learning on the process.
So actually the Seebo solution belongs into quadrant number 1, right?
Yes, that's right. Seebo has a pure focus on specific manufacturing challenges that are process-driven and that has high frequency. Seebo actually built process-based artificial intelligence. We use supervised machine learning, and our expertise is to solve problems around this quadrant.
Thank you, Liran, and thank you all for watching. If you enjoyed this video, you can check out our other videos on our channel, and be sure to click the subscribe button, and we will see you next time. Thank you.